Okay, here's our example problem. Find the area enclosed between y equals x plus 4 and y equals x squared minus 2x for x greater than 0. So, you may want to pull out a graphing calculator or use Wolfram Alpha to graph the pictures, or practice a little bit of graphing by hand. Y equals x plus 4 is a straight line, and it has a slope of 1, and it intercepts the y-axis at 4. That's the straight line there. And x squared minus 2x is a parabola. It opens upwards. You can find pretty quickly where its vertex is. Since you have calculus, you can find the vertex by taking the derivative and setting it equal to 0. You get 2x minus 2 equals 0, and so you figure out quickly that the vertex is at x equal to 1. And you can also see that it crosses at 0. It crosses the x-axis at 0, or by plugging in x equal to 0, you get y equal to 0. So there's a pretty good picture of it. Now what that doesn't tell me is where those two curves, the straight line and the parabola, cross. That's that question mark. So when it asks for the area enclosed between, then I need to find that question mark x value. Before I do that though, step one, once I have the picture, I can say I need to figure out how to slice it. So these are my steps. Step one is decide how to slice. So basically that means I need to pick between type 1 and type 2. This turns out to be type 1, and there's my reasoning. Since the top and the bottom of the slice are the two functions for the same two functions for every slice. There's the top function is that x plus 4, the bottom function is the parabola. Every vertical slice, I see that on top and bottom. Notice that in contrast, if I drew horizontal slices, that would not happen. Some horizontal slices would have a vertical line on the left and a curve on the right. Other horizontal slices, like at the very bottom, close to the vertex, those horizontal slices would have the curve on the left and the right. And then at the very top, some of them would have the straight line on the left and the curve on the right. But it would not work to try and set it up as a single integral. So this is type 1. I need to find that missing, called x equal b, the right-hand endpoint. That's the intersection that's marked with a question mark there. So to find that, I just set the two curves equal to each other, and that'll tell me the x value where they cross. So x squared minus 2x equals x plus 4, and we do the algebra. Subtract the x and the 4. These factor nicely, so I don't need the quadratic formula. And I get x equal to 4 and x equal to negative 1. Now, two answers, but I know that in the problem it said x greater than 0. Let's see, yeah. And from the picture, that's how I drew it as well, the question mark must be the x equal to 4 answer. So now I'm ready to set it up. Set up the integral. I know the start and the stop, that's x equal to 0 to 4. And I know the top function is x plus 4, the straight line, and the bottom function is x squared minus 2x. So I put a minus between those, and then dx, since it's a type 1 dx area. And then you simplify and solve it. You have to be very careful with the parentheses, especially since you're subtracting an entire function. That minus in the middle has to be minus the quantity parentheses, x squared minus 2x. So that when the minus goes through the parentheses, I get minus x squared, and I get plus 2x. So it simplifies to 3x plus 4 minus x squared. There's the antiderivative, just all the raising and dividing. And then I plug in the 4 and the 0. I get 24 plus 16 minus 64 thirds. And that I could work it by hand or on a calculator and get the fraction 56 thirds as the final answer.